Hello, I'm going to be talking a little bit about the Pleistocene Epoch and the major events within it. So, what is the Pleistocene Epoch? It's what is commonly known as the most recent ice age, characterized by repeated glacial cycles. The Pleistocene Epoch began approximately 2.6 million years ago and ended approximately 11,700 years ago. This time period is approximate because experts in the field are still debating when exactly this epoch began and ended. As you can see in Figure A, the Pleistocene epoch occurred between the Pliocene epoch of the Neogene period and the Holocene epoch of the Quaternary period. It is unofficially divided into 4 ages: the Glacian, Calabrian, Ionian, and Terrantian, of which the Glacian and Calabrian ages are considered official. The 3 main events that I'm going to talk about in this presentation are glacial advance and retreat, extinction, and evolution during the Pleistocene epoch. How do we know so much about this epoch? Well, since we are in a physical geology course, let's discuss the different geological records used to study the Pleistocene epoch. One of the most useful records is determining the chronology of this epoch was the marine oxygen isotope record. Microfossils that accumulated on the ocean floor contained shells made of calcium carbonate, which contain a ratio of 2 oxygen isotopes, oxygen 16 and oxygen 18. From these shells, geologists were able to decipher the climate under which the shells were made. What they found was that shells that were formed in colder water during periods of glaciation contained more oxygen 18 than those formed in warmer water during periods of interglaciation. Another geological record that helps provide evidence for glaciation, interglaciation, cycling is the Loess Paleosol record. Loess are deposits of wind-blown dust and silt and accumulate during colder, drier climates like that of glaciation. Along with loess, paleosols, or colorful buried soils, form during warmer, wetter climates like that of interglaciation. From these records, geologists were able to determine that a total of 17 glacial periods and 17 interglacial periods occurred during the Pleistocene epoch. Figure B shows examples of loess and paleosols that formed during the Pleistocene epoch. So what is meant by periods of glaciation and interglaciation? Glaciation is when the Earth was covered by large ice sheets called glaciers. Interglaciation is the period between glaciations when the ice sheets melted and temperatures were warmer. The Pleistocene epoch is characterized by its repeated cycles of glaciation and interglaciation, also referred to as glacial advance and retreat, respectively. Most of the ice sheets were in the northern hemisphere, some, like the Laurentide ice sheet, stretched as far down as southern Illinois. An important aspect of glacial advance and retreat is its effect on plate tectonics. The lithosphere, or Earth's crust, was pressed downward as a result of the weight of the glaciers. Earth's mantle accommodated this downward force by rearranging its soft components. This movement of the lithosphere and mantle in response to a weight is known as isostatic movement. When the weight of the glaciers was removed by the ice melting, the lithosphere rebounded. This is demonstrated in Figure C. Part A of this figure shows the downward movement of the crust when the glacier is present, and Part B shows the crustal rebound after the glacier melts. Most people, when they think about the Ice Age, they think about woolly mammoths and sloths like that in the animated movie Ice Age. The reason these animals are associated with the Ice Age is because they became extinct in a massive megafaunal extinction towards the end of the Pleistocene epoch. The animals shown here all became extinct during this event. The animal on the left of Figure D is a woolly mammoth, and the animal on the right is a mastodon. These are thought to be ancestors of the modern-day elephant. Figure E displays the extinct ground sloth, and Figure F displays the extinct giant beaver. With the exception of the evolution of the genus Homo and this massive extinction event, most of the fauna and flora that existed back in the Pleistocene epoch still exists today, with very few evolutionary changes. A quick note about how or why this massive extinction took place. Experts have narrowed it down to two hypotheses, one being the overpredation of these animals by human hunters, and the other being a result of the drastic climate changes accompanied by the glacial cycles. As with any hypothesis, there are pros and cons, and the same applies to these hypotheses as well. The first hypothesis makes sense since the evolution of the genus Homo occurred around the same time. But experts have countered this hypothesis with the notion that these animals were too large and human hunters were not yet skilled enough to make such an impact. Figure G compares the extinct ground sloth with a human figure. As you can clearly see, the ground sloth was much larger in size than the human. The second hypothesis of climate change attributes the extinction to the migration of vegetation and other food sources when the Earth was covered with ice, and when that ice melted. Most experts agree that a combination of these two hypotheses can account for the massive megafaunal extinction during the late Pleistocene Epoch. It is important to understand the past when looking toward the future. Geologists studying the Pleistocene Epoch hope to gain insight as to the causes of these glacial cycles. Was it astronomical cycles? Was it the presence of carbon dioxide in the atmosphere? Was it the dynamic ocean-atmospheric relationship? All of these theories are being tested with the hope of predicting future climatic changes and the impact of humans on these changes. Right now, the Earth is in a period of deglaciation, or simply warming. This has happened before, so why are scientists freaking out about global warming? The main concern is the rate at which the Earth is warming. Figure H provides an excellent reconstruction of global warming with and without human influence. The key is to determine how much of the rising temperatures is caused by natural cycles and how much is caused by humans. This way, we know how best to reduce our impact. So, to summarize, the Pleistocene Epoch occurred around 2.6 million years to 11,700 years ago. Marine oxygen isotope records from microfossils provide excellent evidence for the chronology of the Pleistocene Epoch. It was characterized by periods of glaciation, where large sheets of ice covered much of the Earth, punctuated by periods of warming, which melted the ice. This cycling resulted in isostatic movements of the lithosphere, where the crust would sink under the pressure of the ice and rebound when it melted. Finally, the Pleistocene Epoch ended with a massive megafaunal extinction due to a combination of the evolution of the genus Homo and drastic climate change.